Hello, everyone. My name is Mete Atamel. I'm a developer advocate at Google. I'm based in London, and it's my second time in NDC Oslo. It's always great to be here. I'm going to be talking about Istio. These slides on my talk, they're already on Twitter because I gave this talk recently. So if you want the slides, you can just follow me on Twitter. The demo that I'm going to show you with the steps, it's already on my blog as well. So if you want to do it yourself, you can just follow that as well. I'm going to have these links at the end of my talk, too. So if you want to get the links to them, it's OK as well. We also have so I work for Google Cloud, and we have a .NET developer survey that we've been asking people to fill for us. We're basically trying to understand what .NET developers do nowadays when it comes to cloud and what tools they use, and if they heard of Google Cloud and if they're using Google Cloud, things like that. So if you have time, we would appreciate if you can fill that. The idea was that you would fill the survey and we would give you some swag, but unfortunately our swag got stuck in the customs in Norway, so I don't have anything to give to you other than just thanks. So I'll just keep that for like 10 seconds, and then we can start the talk. All right. So the agenda is like this. My talks, they usually have the same kind of pattern. I always start with why, and then what, and then how. The why part is basically every time there's a new piece of technology, I think it's important to ask why we should even care about this technology, because there's so much to learn, and we can't learn everything. So I think it's important to cover the why part initially. Then after that, we're going to talk about what. So what is Istio? What kind of problems it's trying to solve? And then we'll get into how. So I'll try to show you a demo and then get into details of how things work with Istio. But in terms of the agenda, basically, we'll talk about containers and Kubernetes just briefly, just to make sure that everyone is on the same page. Then we'll talk about the Istio at the very high level. And then we'll get into details of Istio with MOI, Mixer, Pilot, and Istio Auth. Then once you have the basic Istio working, you can add on a lot of plugins like Grafana, Prometheus. We'll take a look at those, how you can add them on, and what do they give you. And finally, traffic management. The coolest thing about Istio is that once you have the service cluster working, you can change the traffic rules about it. So you can define how the traffic flows within the system, and you can set policies on it dynamically. So we'll take a look at that, and we'll also try to run some live demos to make sure that we can see it. So that's kind of a rough agenda. Usually I do this talk in 40 minutes, so we should probably have some time for questions in the end as well. But if not, I will be outside at Google Cloud booth anyway, so if you don't have time, you can come there for questions. All right, first of all, let's talk about the need for Istio. Why should we even care about Istio? Who is using containers today in production? OK, so half of the people, I guess. So for those of you who might not know about containers, or maybe you know about them, but you haven't used them, basically containers at the very high level, they're just another way of virtualizing your applications. And the difference from virtual machines is that in virtual machines, you're virtualizing the whole operating system and everything that goes on top of that. But with containers, you're virtualizing your application and the dependencies of your application. And since you're virtualizing the process and not the operating system, it's much more lightweight. And because of that, it's very easy to create. It's very easy to deploy. It's very easy to move around. So that's why containers, they became the de facto standard recently in packaging your application and running them, especially in the cloud, because it's just compared to VMs, they're just much more lightweight and much easier. And they start with Linux containers, but now we also have Windows containers if you want to run Windows applications. And for me, the most important part of containers is that they're composable. So you can start with a base image that you depend on, your dependency, and you can build your image on top. And if someone else wants to build their image, they can take your image and build on top of yours. So that way you can layer your dependencies layer by layer, and each layer is cached independently. So once you get the base image for one container, you can use it for other containers, stuff like that. So Docker, the concepts of containers, they've been around for a long time. And at Google, we've been using containers for more than 10 years. But the concepts of the concepts of containers, they were brought to the everyday developers by Docker. In Docker, there's this idea of a Docker file. And in Docker file, you define your dependencies, what you depend on. You define your environment that you need. And you also define your application, what you run. So for example, in this case, it's a really simple example, but we are depending on Debian latest image. We are installing some some packages, in this case Nginx. We're exposing port 80 in the container, and we're also defining how to run this application. In this case, it's just an Nginx application. So you define all of this in a Docker file, and Docker, what it does is that basically it makes sure that this context that you're defining is consistent everywhere. So you can run it on your machine the same way, and then this context is also replicated in the cloud. Everywhere there's Docker runtime, you can run this context, and you can rely on the fact that this context is exactly the same way. But containers by themselves, they're not enough, because when you run applications in production, you probably need redundancy. So you need to run multiple containers. You need to create multiple containers, and you need to manage them, make sure that they're running. If your containers are successful, you probably want to scale them up, so you need to create new containers at your cluster. And you probably want to scale down when people are not using them, so you need to think about scaling up and down. You need to think about rolling out new versions of your application. So let's say you have version 1 of your application, and you want to roll out version 2. You need to do that one by one with containers and make sure that they update consistently. And if something goes wrong, you want to be able to roll back to a previous version. You probably need health checks, because how do you know that your container is running? You probably need to worry about configuration and secrets. So how do you define configuration, and how do you get that into your container? So there's all these issues that you need to think about when it comes to running applications, even containerized, but you need to think about this. And just because you took your application and containerized, that doesn't mean that these problems go away. So that's why we have Kubernetes. Who is using Kubernetes today? OK, so it's roughly half of the people. So Kubernetes, first of all, it's a Greek word, as you can see from the Greek letters, that everyone mispronounces, by the way. The right way of saying Kubernetes in Greek is Kybernetes, but Kubernetes came out in the US, and people started calling it Kubernetes, and now we're stuck with the name. But it's a 100% open source container management platform. It's written in Go. It came from something called Borg. So as I mentioned before, at Google, we've been running containers for a long time, and we created an internal container management platform called Borg. So people who worked on Borg, they use it over the years, and they learn from it, and they created Kubernetes for everyone else. So they don't share the code, but they share the concept. So people actually learn from Borg, and they apply that to Kubernetes. And for me, the coolest thing about Kubernetes is that it supports multiple cloud environments. So you can run Kubernetes on Google Cloud, on AWS, on Azure. And you can also run it on your own machines as well. So once you adopt Kubernetes and the constructs of Kubernetes, it becomes really easy, basically, to pick and choose where you want to run it. And that's why most people are adopting it today. So in this containerized Kubernetes world, a microservice ends up being a combination of what you have and a combination of what Kubernetes provides. So for example, in this case, you will have your code, and you will containerize it, because everything is containerized in Kubernetes. So you will have your container, and it will live in some public registry. So this can be Docker Hub, or it can be a Google Container Registry. From there, you create what's called a pod template. A pod is the smallest unit that Kubernetes runs. Usually, it includes one container, but sometimes you can bundle multiple containers into a single pod and get them scheduled together as a unit. So you define that in the pod template, and then you tell Kubernetes what you want to be true. In this case, for example, there's something called replication controller in Kubernetes. We are saying we want to have 3 replicas. So we want to have 3 copies of our container running at all times. So replication controller will look at what you want, and then it will look at the resources that you have, in this case, virtual machines in Google Cloud. And then it will figure out, it will create the pods, and it will figure out how to schedule them. So it will figure out the right place to schedule them, so that scheduling becomes not your problem anymore. It's Kubernetes' problem. And then once you schedule them, and the pods are running, you want to expose them to the outside world, you create something called service. Service is basically a load balancer for pods, and the service will have a stable virtual IP, and people from outside will get to the service, and from the service, it will get to the pods. So in this containerized Kubernetes world, a microservice ends up being a combination of your container and combination of replication controller, creating and scheduling your containers, and service exposing your container, and many other things that Kubernetes provides. But I won't talk about them in here. But it's a combination, basically. And we need to think about it in those terms. But unfortunately, even though Kubernetes is great, it's not enough either. Because when you run an application in production, you need to think about logging. So what logging framework do you want to use? You probably want tracing. So when you make an HTTP call in your cluster, you want to be able to see like where the time is being spent in your HTTP calls. You probably want some kind of metrics. So how do you collect metrics? Where do you send them? How do you visualize them? There's all these kind of problems. When you go beyond metrics, you probably want to be able to see the dependencies between your microservices. So who depends on what, and how the traffic is flowing in your system. You probably want to set some policies on your traffic. So you don't want everyone to call everyone else. You probably want to set some kind of policies, and you want to be able to enforce them as well, right? And it would be nice to do fault injection. So if you have some kind of timeouts in your system, you probably want to inject some delay in your system and see how your microservices behave. So just because you took your application, containerized it, and just because Kubernetes is watching your containers doesn't mean that these problems go away. You still need to worry about them. So that's why we have this. This is the logo of Istio, the ship. And Istio, it's another Greek word. It means sail in Greek. I don't know why open source people are obsessed with Greek, but that's what we have. The good thing is that people don't mispronounce Istio. Istio is Istio in Greek as well. That's good. It's an open source framework basically for microservices. It's about connecting, managing, and securing microservices. So you can think of Docker as the thing that gives you the context, the consistent context. And then Kubernetes schedules your containers and watches your containers and makes sure that your containers are running. And Istio is built on top of Kubernetes, and it helps you with the microservice level problems that I mentioned. So it's at a higher level than Kubernetes, and it lets you do more than what Kubernetes does for you, basically, for microservices. And we will look at the details of that now. But before we look at the details, I think there are like two high-level goals of Istio that I want to mention. The first goal is, I think Istio is about the community coming together and gathering around common tools, right? Because we all want logging, we all want tracing, we all think that service dependency visualization is good. So why do we need to reinvent the wheel every single time and try to start from scratch? So instead, we have Istio now that kind of picks and chooses the best tools for the job, but at the same time, it's extensible enough to plug in whatever you want. So if you don't like some kind of framework that Istio provides by default, you can plug in whatever you want. So that's the goal, at least. So that's number one. And the second goal is that, normally when you write your application code, ideally you shouldn't have any kind of awareness of the environment that you're running. Your application code should only solve application problems. But that's really hard to do. Like, you always have the details of the environment seeping into your application code. But Istio really gives you a framework where you can cleanly separate your application code from the underlying infrastructure. And we'll look at how that works in Istio as well. So let's imagine that you have a microservice like this. So you have users talking to a front end. Then maybe front-end microservice is talking to a pictures microservice and a payments microservice and an authentication microservice. And the authentication microservice is it's using a SQL database in the backend. And then maybe the payments is using an external payments processor. So let's imagine that you have this kind of setup in your microservice cluster. If you want to introduce Istio here, this is how it will look like. So a couple of things to, first of all, realize is that first you have, at the end of your microservice cluster, you have ingress, public ingress, and private ingress. So that's for public traffic coming in and private traffic coming into your system. And on the other hand, you have egress. So that's outgoing traffic as well. So all the traffic will go through ingress, where you can actually apply some rules. And then all the external traffic could go through egress if you want. So if you want to make sure that you can all the traffic goes through egress, you can do that. But you can also do direct calls as well to the external traffic. So in this case, all the calls for authentication, we make sure that it goes through egress. But then maybe payments, you don't want it to go through egress. If that's what you want, you can do that as well. And then all the traffic within the service mesh itself, it goes through these proxies. So every container will have a sidecar pod attached to it with proxies, and all the traffic will go through the proxies. So from ingress, you go to the proxy of the front end. If front end needs to make a call to the pictures microservice, the proxy of the front end will make the call to the proxy of the pictures, and so on and so forth. And because the traffic is going through these proxies, Istio can do a lot of interesting things, and we'll talk about what those things are. But basically, you have ingress, egress, and you have the proxies in the middle. So that's what Istio provides to you at the base level. Now, how do you use Istio? Well, first you need a Kubernetes cluster. So to create a cluster, at least on Google Cloud, you would just say gcloud container clusters create, give your cluster a name, give your cluster a version. So that was the version that I used for this demo. Specify the number of nodes that you have for the containers, and also specify the zone. In this case, I'm in UK, so Europe West 1B. So that's just creating a regular Kubernetes cluster. There's nothing special about it. Once you have the cluster, you need to create a cluster role binding. So you need to do that so that Istio can manage the cluster for you. So that's the only special thing that you need to do to get a cluster ready for Istio. Create the cluster and create a cluster role binding. And now this cluster is ready to be managed by Istio. So now I want to show you how to actually install Istio. So I didn't. These steps that I mentioned, I already did them in here. So I already have a cluster in Google Cloud called Hello Istio, and it has 4 nodes where I can schedule containers. Now I want to install Istio here. So what we need to do is, so I already have my shell, and I have my instructions here in case I forget. So this is creating the cluster. But what I want to do is first I want to make sure that kubectl config current context. So I want to make sure that I am actually running against the right cluster. So that's Hello Istio. That's great. So what you would do is first you would download Istio. I have 2 versions. 0.7.1 was the version that I've been using for a long time. But then before I came here, I realized that there's a new version of Istio, 0.8. So I downloaded it as well. But one thing I realized is that they changed a lot of things in 0.8. And that changed quite a bit of things in my demos as well. But I will talk about the changes from 0.7 to 8 in case you've been using Istio. So let's go to 0.8. And I just want to take a quick look here, what you get by default when you download Istio. So this is 0.8. So by default, you get a bin folder, and in here there's Istio-ctl. So for those of you who know Kubernetes, there's kubectl to manage Kubernetes, and for Istio, there's Istio-ctl to manage Istio. So you would probably have this in your path. So let me, before I forget, add that to my path. So I'll just copy and paste this. So I'm just adding Istio-ctl to my path, and then I'll do the same thing in here, just to make sure that I did it correctly. If I type Istio-ctl, then I know that it's there. Great. And then under install folder, there's a bunch of different ways of installing Istio. So on GCP, on Google Cloud, there's deployment manager. It's a way of defining resources to be installed on Google Cloud. So you can use that if you want. But if you are installing on pure Kubernetes, there's a Kubernetes folder with Helm and with other templates. So I'm going to use one of these to install Istio. And then there's a bunch of other things as well in the install folder. But I'm going to be focusing on the Kubernetes folder. And then there's also a bunch of samples. So there's a Bookinfo sample that I will show. But there's also a Hello World and other samples as well in here. And then under tools, there's a number of tools, but we won't take a look at them that much here. So that's what you get by default. But to install it, what I'm going to do is just let me copy and paste this. So I'm in Istio 0.8. So I'll just say kubectl apply, and then point to Istio demo auth. And as this is installing, we can actually take a look at the demo auth YAML file. So you can, so I mentioned the proxies in Istio, right? They do all the traffic routing. You can have regular calls between them, but you can also have mutual authentication between them. So that's what I wanted to do. So that's why I'm pointing to demo auth. When you point to that, it will make sure that your proxies, they do mutual authentication. And if you look at this YAML file, it's a long YAML file with a lot of things. But basically, it installs all the components of Istio, like pilot, mixer, Istio auth. And then it also installed the add-ons that we're going to talk about, Grafana, Prometheus, Zipkin, all that kind of stuff. So I won't go through it here because it's just a YAML file that you probably know when you install Kubernetes. But it will basically install base Istio and all the add-ons that I need to show you today. So this will take like a minute. And one thing to mention is that when you install Istio in your cluster, it will go under Istio system namespace. So it's always under that namespace. And if you want to delete Istio, you can easily delete that namespace and everything goes away. So if you don't basically need to mess up your cluster, you can easily install Istio, get it managed by Istio. But if you don't need it, you can get rid of Istio and your cluster will still keep running. So once this is done, we will make sure that we have, see, you can see that Zipkin is created, tracing is created. So it's done now. So what we can do is kubectl get pods, namespace, Istio system. So this will tell us all the pods in Istio system. So Grafana is an add-on. Citadel is the name for Istio auth. It's for authentication that I'll talk about. There's egress gateway, ingress gateway that I'm going to talk about. There's some post-install pods. Some of them are errors. I don't know why, but one of them is completed, so it should be fine. Then there's pilot, sidecars, tracing, Prometheus service graph. So everything seems to be working. And if we do kubectl get service, there's some default services. So there's an ingress service. There's an there should be an egress, I think. There's service graph, tracing, Zipkin. So they're all there. There's an egress gateway. Yeah. So I think that's it. That's all you need to do. Yeah. And the next step will be to deploy application. But before we do that, I have some slides to show you. All right, so we installed it. So what do you get in Istio? In a single slide, I just want to point everything in a single slide. First of all, you install Istio on Kubernetes, but the intent is that Istio should work on Mesos and Cloud Foundry as well. At least they try to make it platform agnostic. Right now, Kubernetes is the main platform that all the work is being done. But I know that in the future, Mesos and Cloud Foundry will be supported as well. The current version is 0.8. As I mentioned, it just came out in May. So what does Istio give you? It gives you observability features. So you get metrics, logs, traces, dependency visualization for free. Your services get identity. So every service has an identity. And you get security. So you get mutual authentication between services. You get traffic management features. So you can set rules between services. And you can specify who talks to what. And then you can enforce policies. So the rules that you set, they get enforced in Istio. So in a nutshell, this is what you get in Istio. But the key thing is that you don't change your application for this, right? Your application you deploy as normal, but because of the proxies that gets installed next to your application, you get all these features for free. So to me, that's like the biggest selling point of Istio is that you don't have to change your application. You just install Istio and you get all these features. So in terms of the building blocks of Istio, this is how an Istio cluster kind of looks like. So you have your microservices like front-end and then payments. Next to them, you get these proxies, and then you have a control plane. So control plane are the things that help proxies do their job. At least that's how it is in my mind. So proxies, they do the job of connections, like HTTP1 connection, HTTP2 connection, or gRPC connection with or without TLS. And proxies, they also do like load balancing, service discovery, all that kind of stuff. But the control plane, like Pilot and Mixer and Citadel, they try to support proxies to do their job. So in terms of supporting, Pilot is all about discovery and configuration. So if a proxy wants to talk to another proxy, it will ask Pilot, where is this other proxy? And Pilot will keep track of that. Actually, Kubernetes will keep track of the service, and then Pilot will ask Kubernetes, and then will tell the proxy. So for service discovery, proxy will depend on the Pilot. And also for configuration, if you want to configure proxy, a user will talk to the Pilot and tell the Pilot what the user wants, and then Pilot will translate it to the specific rules that proxy needs, right? And Mixer is all about telemetry. So proxies, as they route connections, they will send some metrics to Mixer, and Mixer will collect them, and also do the policy check. So if there's any policy between two microservices, proxies will ask the Mixer, can I make this call? Is there a rule that prevents me making this call? Or is there like a limit that prevents me to make this kind of call? Mixer will keep track of all of that. And Citadel, which used to be called Istio Auth, is all about TLS and mutual authentication between proxies. So all that kind of stuff is maintained by Citadel. And just to mention, Envoy Proxy, it's an independent project that came from a company called Lyft, and it's written in C++, and it's supposed to be highly efficient proxy. So it's supposed to introduce minimal latency, and it does all the heavy lifting in Istio. So service discovery, load balancing, HTTP connections, gRPC connections, they all go through Envoy. There's a little bit of performance hit because there's a proxy in the middle, but it's supposed to be really efficient. And it's been tested independently of Istio by Lyft on more than 10,000 VMs and millions of requests per second. So it's been tested and optimized for those kind of use cases. But there's a little bit of overhead just because the traffic is now going through the proxies. And Pilot acts like a good abstraction layer, both for the envoys, both for the proxies, and for users as well. So for users, when you want to configure your proxies, you will talk to the Pilot through a rules API. So there's a rules API. And Pilot will take those rules API, and it will convert that into platform-specific rules. So if you're running on Kubernetes, it will take the rule and apply and basically convert those rules into Kubernetes rules. But if you're running on Mesos, it will convert to Mesos rules. So it will basically make users unaware of the platform that you're running on. At the same time, envoys, if they want to discover a service or if you want to know the traffic rules, they will talk to Pilot through the Envoy API. And then again, Pilot will ask the underlying platform on behalf of Envoy. So that way, envoys, they're also abstracted away from the underlying platform. And then last thing I want to mention here is that you don't have to install Istio as a whole. So if you want to pick and choose what you want to use in Istio, you can. So you can only install, for example, you can say, I want to install Pilot and get service discovery and nothing else. You can do that. Or maybe you want to do Mixer and policy checks and telemetry and nothing else, you can do that as well. So you can pick and choose what you want to use and install just those if that's what you want. All right, so that's Istio in a nutshell. What I want to do is I want to show you a simple application called Bookinfo application that comes with Istio. In this application, we have a front-end page called product page. It's written in Python. And then it's talking to some backend services. So there's a Java backend called reviews. But it has 3 different versions, so there's V1, V2, and V3. There's a details microservice written in Ruby, and there's also a ratings microservice written in Node.js. As you can see, these are different microservices written in different languages, but with containers, it doesn't matter, because as long as you can put it in a container, you can use whatever language you want, and we don't care, which is a nice thing about containers. So what we're going to do is we're going to take this app and we're going to install Istio here. So once we install Istio, it will look like this. We will have an ingress for the incoming traffic. Then we're going to have, for each microservice, we're going to have a sidecar attached to it for the traffic. And then we'll just play with it and see what kind of stuff Istio will give us. So let's do that. So I'll go back here. So to deploy the application, I'm just going to copy and paste because I'm not good at typing live, but I will explain what this is. So what I'm doing here is I'm doing kubectl apply, and in Kubernetes normally you'll say kubectl apply -f, and you would just point to the YAML file. So in this case, Bookinfo YAML is the YAML file that will install the application. But instead of doing that, I'm doing this istioctl kube inject. And the reason why I do that is that I want to make sure that when my pods are created, the Envoy proxy also gets created alongside with my pods. And to do that, basically I'm doing a kube inject with istioctl command. So I'm doing manual injection. There's also a way to set this up so that it's automatic injection. But for that to work, you need to set up some webhooks in Kubernetes, and it takes a little bit of time to figure it out, so I don't do it live. But there's an automatic way of doing this as well. But in this case, I'm just doing a manual injection. So I'll do that. And this should install all the microservices on for Bookinfo application. So if I do kubectl get pods, now this is in the default namespace. They're all running. You can see that I have the details v1, product v1, and ratings v1, and then reviews as 3 of them. And if I do kubectl get service, I also have the services running. That was quick. So in Istio 0.8, what you need to do is you need to create a gateway for incoming traffic. To do that, I need to run another command. So this time we're going to use istioctl. And this will create a gateway, basically an ingress, so that the incoming traffic is enabled. And I'll talk about gateways later in the presentations. But let's do that. So there's a gateway. And to get the gateway IP, we'll run a kubectl command. So I'll just say, get the service of Istio ingress gateway. So this is the external IP, and this is the port where my gateway is running. And that's the one that I'm going to hit to test my application. But before I do that, I just want to set some variables so that it's easy for me to test it. So I'm going to set a variable called Istio host for the IP. And I'm going to set an Istio port for the port. And let's create a gateway URL, just a combination of the host and the port. So if I do echo gateway URL, you can see that it's the IP and the port over here. Great. Now I can actually do a curl and see if my product page works. So let's try that. And for curl, I need to get rid of these slashes. So if I do this, it's hitting the IP and the port and the product page. And if everything is working now, I get 200. And just to look at the page itself, I just want to show you the actual page. So let me just copy this. Come here, /product page. Yeah, so this is the exciting application. It's very simple, but this is the front end. This is talking to the details microservice. This is talking to the reviews microservice. And when I refresh, just watch what happens with the reviews. So if I do refresh, it keeps changing, right? Because every time I do a refresh, it's doing a round robin between different reviews microservices, because I have 3 different versions, and that's why it keeps changing. But later, we'll fix that by setting some rules in our cluster. But the app seems to be working, which is good. And let me see if I want to show anything else here. Yeah, that's all I want to show. But let's keep moving on with the add-ons. So that's the app. So now we have the basic Istio working, and we have the application being managed by Istio. As you've seen, like, I haven't done anything special with my application. It's just a regular application. But by injecting proxies, now it's being managed by Istio. And that's how it works. And once you have the base Istio working, you can add add-ons. So you can add on Grafana. Who's using Grafana here? So OK, so you know what I mean. So you can use Grafana to visualize metrics. You can have Prometheus to query the metrics. You can have Service Graph, which is my favorite, to see the dependencies of your application. So in this case, for example, you can see that there's an ingress, there's a product page, and all the different versions of our application. And you can get real-time updates on requests per second, bytes per second, stuff like that. And you can use either Jaeger or Zipkin for tracing as well. So these are all the things that you can add on individually. But in the demo YAML file, we already have these, so I already have them installed. So let's just take a look at how they work. So to get things working, I need to do port forwarding. So let's take a look at, well, before I do that, let me just send some traffic. So on this page, I will just say, I'll just do some curl and send some traffic. Oh. Yeah, so this will send, yeah, it's sending some traffic. And in the meantime, I will just do port forwarding for Grafana. All right, so if I go to port 8080 now, so this opens up Grafana. So if you know Grafana, this is not that exciting, but the point is that it's just an add-on you can add on. And what you have is, by default, you get some dashboards for Mixer and Pilot. So if you want to look at details of Istio, you can. But Istio dashboard is where you see your application. And since we are sending traffic, you get the request per volume. You get the success rate, which is 100% here. You can see all your microservices. Let me make this a little bit bigger. With ingress gateway, with different versions of your reviews, version 1, version 2, version 3. So all this stuff happened because we let Istio manage our application. The next thing that I want to show is the Prometheus. So if you want to actually see the metrics and ask questions about them, you can use Prometheus. So let me just kill this. We don't need it. Oh, see that it's killed. And now let's go to port 8083. So this is Prometheus, for those who know. And by default, we get some metrics. So if we look at like Istio request count, let's make sure that I'm still sending some traffic. I can execute, get some numbers, and I can also see a graph that updates in real time. So that seems to work. We can take a look at service graph. So in here, let's kill this guy. I'm again setting port forwarding to service graph. And let's do localhost 8082. So this is the default service graph you get. And this updates, like if you refresh, it will update. But you can see that everything goes through ingress from the product page. Then it goes through different microservices that we have in our cluster. So it's very useful to visualize what you have in the cluster. And last thing I want to show is tracing, HTTP tracing. So for that, there's like Zipkin and Jaeger. But let's take a look at Jaeger. It looks nicer. So that's 8084. So we get this, and we can take a look at different parts of Istio, but let's look at product page and find traces. Then we can see what happens on the product page, how long things are taking, what other microservices are being called. So you get this again by default by just letting Istio manage your application, which is nice. And let me see if there's anything else. I think that's all I want to show here. Stop this. All right, so we got Istio working, we got our application, we got our add-ons, and last part I want to talk about traffic management. So what do you get for traffic management in Istio? First of all, you get discovery and load balancing. So we'll take a look at what that means for your services. You get dynamic request routing. So you can change how the requests go from your service to another service dynamically. And you can do fault injection and failure recovery. So you can add timeouts to your calls. You can do retries. You can add circuit breakers. You can inject faults into your calls and see what happens, and you can inject delays as well to your calls and see what happens. So for example, if your service A wants to make a call to service B, it will just make a call to serviceb.example.com. This will go to the envoy. Then envoy will ask the pilot, where is the service? Pilot will use Kubernetes service discovery to figure out where it is, and then it will route you to that service. But then if you set a rule in pilot so that 99% of the traffic goes to a version of your application and 1% goes to a new version, you can do that, and that will be done transparently. So your service A wouldn't know about that. It will just make a request to service B. But under the covers, because of Envoy and because of the rules API, you can set these rules and the traffic can be split like that. And similarly, you can do like user agent matching. So you can say, if my headers, they have user agent Android, I can send some of them here. But then if my user agent is iPhone, then I can send it to a new version as well. So all of this is done transparently to your services. Your service doesn't know about this. It's just the pilot that knows about it. And then for failure, as I mentioned, you can set retries. So you can say, I want this service to try 3 times before it fails. So Istio will try it 3 times on behalf of you. So you don't have to do that in your application. You can limit the number of concurrent connections to a microservice in order to not overwhelm your microservice. You can add health checks and circuit breaks and all the stuff that you want to do. Istio has something for it, and you can just add them on into your service mesh. And also, fault injection is a good one. So let's imagine you have a front end, movies and stars, and they have timeout between them, like 100 milliseconds and 3 retries. And then this other one has timeout of 200 milliseconds and 2 retries. So you can add delays to your calls. For example, you can add 300 millisecond delay here and see what happens with your microservices. Do they behave the way they're supposed to behave? Similarly, you can add another delay here that's different than another one and see how it behaves. This is really good because it's very hard to test this kind of stuff in production and see what happens. So you can actually simulate it and see what happens. So let me show you some of this in the demo application. So as I mentioned, remember like in the Bookinfo application, when we refresh, I still have it, I think. So when we refresh, the reviews, they keep changing because we have 3 microservices. What we can do is we can actually pin our microservices to a specific version. So let's try to do that. And to do that, what we're going to do is we're going to create what's called a virtual service. So virtual service is something new in Istio, in 0.8. But if you look at virtual services, this is what you get. There's a gateway, and then these are the paths that your virtual service handles. But now the virtual service, it doesn't have any like version information. What we can do is we can run this command. Istio create. So this creates what's called a routing rule. And this routing rule will make sure that all our microservices are pinned to version 1 of our service. So let's, I don't think I'm in the right place. Yes. So let's run again. Now this created virtual services for all the different microservices. So there will be virtual services pinned to a specific version, and also destination rules. So I will talk about what destination rules are, but basically, once you create a service, you define what kind of rules you have on that service. So that's why we also have destination rules. So once we do this, if we go back to our application and do a refresh, now you can see that we have a pinned reviewer. I'm refreshing right now, but it doesn't change because we pin all of them to version 1. So we dynamically changed it. You can also pin like certain users to certain microservices. So imagine you have a testing account and you want to test certain accounts with certain versions of your application. You can do that. So in this case, I'm gonna run this command. And I'm basically replacing the rule with another rule that says route rule reviews test v2. And we can actually take a look at that. Let's run it first. And let's take a look at how that looks like. So if we go to samples, Bookinfo, routing, what was the name? Route rule reviews test v2. Test abort. It's this one. So in this rule, we create a virtual service, but this time we are doing an HTTP match. So we are basically looking at the cookie, and we are doing a regular expression match. And if that cookie has the user JSON in it, then we are going to the version 2 destination rule, meaning we are going to the version 2 of our application. And for everything else, we go to version 1. So if we match JSON, we'll go to version 2. For everything else, we go to version 1. So with this rule, what happens is that if we come back here and I sign in as JSON, then you see that this changed. And if I keep refreshing, then it will stay with that one. So we are on version 2, I guess. And then if I do sign out, then we are back to normal, where we are pinned to version 1. So we can dynamically change it for users as well. And then if you want to get rid of rules, basically just point to your YAML and just delete the routing rule. And this deletes all the virtual services and destinations. And we can come back here, do a refresh, and now things are back to normal where they are. And if you want to get rid of Bookinfo and Istio as well, it's very simple. So I will do this. There's a script that runs to delete all the resources for my Bookinfo application. So this deletes the virtual services and the gateways that my Bookinfo application has. And it will also delete the pods and the services that it has in Kubernetes. And to delete the Istio, we'll run this one. So if I do here kubectl get pods, now they're terminating. But if I do kubectl get pods Istio system, we still have Istio running, yes. So get rid of it. I just point to my YAML again. And now we also have Istio out of our cluster. And now you have your cluster back to where you were, basically. So it's very easy to add and remove. I think that's all I have here in terms of demo. And to go back to presentation. Yeah, so now from now on, I would just want to briefly talk about 0.8, because these are new stuff that I just learned myself. But I just want to mention my understanding of it as of today. So as I mentioned, this is how an Istio cluster looks like. So there's ingress, public and private. There's egress, and there's like proxies in the middle. So how does that translate into Istio 0.8, the latest version of Istio? First of all, if you are using Istio before 0.8, like me, you had the ingress rule for the ingress part. You had the egress rule for the egress part. And then you would set routing rule and destination policies to control the traffic. So those are the constructs that you had before. But in 0.8, you have new things. There's gateways basically for the ingress. And then you have virtual services, which is a combination of all the destination rules. So you basically combine all the destination rules into a virtual service. And then you have service entry for the egress. So you define what goes out of your cluster through service entries. So just to look at them briefly, basically this is how it looks like. So gateway handles like the high-level HTTP and HTTPS. Once you have that, you get into virtual service. And then virtual service kind of combines your destinations into a service. And then from the virtual service, you have different rules for the destination. So you might have a single service that has multiple versions. Those versions will be defined in the destination rules as subsets. And then they will be combined together into virtual service. And then after destination rules, there's service entries for external traffic, but I don't have it here in this diagram. So as I mentioned, gateway is kind of like the entry point to your cluster, and it handles HTTP and HTTPS traffic. So that's how you start with, like in Istio mesh, that you would define a gateway. And it kind of looks like this. So basically, you give it a name, and you define your port and your protocol and your certificate and stuff like that, but nothing else. So it's very basic. So it's the gateway to your mesh. A virtual service is kind of like a combination of your destinations into a service. So you can have multiple virtual services, but they all need to be part of a gateway. So from gateway, you get to the virtual service, and they replace the route rules that you had before in Istio, before 0.8. So the way you define a virtual service is you first point to a gateway, so you know how to get into the service mesh. Then you define the actual endpoints that your service defines. So in this case, the reviews will be defined in here. And then if you have different kinds of rules, like for example, if you want to define what I defined with the HTTP headers with user JSON, you can define a rule for that, and that will point to a destination rule. And that will say destination version 2. So you define the rule here, and then you define the destination in a destination rule. So that's how things work. So V2 will be defined in a destination rule. So you can think of virtual service as like an aggregation for all the destination rules that you have. Then you have destination rules where you define what kind of policies you want to be applied at this point. So you got through the gateway to the service, and from then on, you want to be able to define what happens, what kind of rules you want to apply. For that, you can apply destination rules. They used to be called destination policy. They changed it to the destination rule. I don't know why, what's the difference, but that's the way it is right now going forward. And the rule can be, you can do like load balancing, like random load balancing. You can say the subset is, if V1, then it points to version 1. That's the label of the pod, I guess. Or version 2 with different kind of load balancing. So all that kind of rules, they happen within the destination rule. And service entry is basically just egress rule. So you define it for external traffic. For example, in this case, we can say we are enabling all the traffic to star foo, and all the HTTP and HTTPS traffic. So if you define this, then all the traffic to foo.com will be enabled with AT and 443. So these are new things in Istio 0.8, and I just learned about them myself, and I'm trying to understand how they fit with the previous Istio. But they just recently renamed all of that, and there's a blog post on this on Istio page that you can read about. The cleanup I already showed you, and I think that's it. That's all I have here. So if you want to go through these steps yourself, there's a blog post as I mentioned. If you want to follow Istio, this is Twitter, and then there's also an Istio-users Google group where you can actually ask questions, and people are quite active there. And as I mentioned at the beginning of my talk, we have a survey. So if you have time, if you can fill a survey for our .NET offerings on Google Cloud, we would really appreciate. So yeah, that's all I have. Thanks very much. I think we have 10 minutes, so if anyone has any questions, I can answer. Yes?
If it's creating a new ingress endpoint, does that conflict with Let's Encrypt? Like we use Insert Manager for Let's Encrypt.
Yeah.
Is that combined or is that included?
Yeah, I mean, you would basically specify your certificates in that ingress rule. In the gateway, you will specify that.
So you run it parallel to. So ingress now is talking to the load balancer in Google Cloud, but then Istio will be doing that instead, I guess.
It still goes through Google's Cloud Load Balancer, but then you basically create a gateway to enable it to your service mesh. Yes?
Does it work with the Google L7 load balancer as well as the?
No, I think it's L4 and L6. That's what it works with, not L7. Yep. Any other questions? All right. Thanks very much again.